Svenska Kraftnät is building a vital new highway for Stockholm's electricity supply. This is a 13.4-kilometre long tunnel between Danderyd and Hammarby Sjöstad for 400 kilovolt electrical cables and 6 ventilation shafts. The cable tunnel is part of an investment to reinforce the electricity network and safeguard Stockholm's electricity supply. The tunnel is being constructed using a tunnel boring machine. A joint venture between Hochtief and Implenia acts as the contracting company. Work in the tunnel is taking place 24 hours a day in multiple shifts. The teams working these shifts consist of people highly experienced in tunnelling, specifically working with tunnel boring machines. The people working in the tunnel are transported in a specially designed vehicle that has driver's cabs at both the front and the rear. This vehicle also transports material and equipment into the tunnel. The tunnel boring machine Electra is 240 metres long, weighs 1,000 tonnes and is manufactured by Herrenknecht in Germany. It's powered by electricity and requires approximately 3 megawatts of electrical power. At the very front is the cutter head, followed by 20 service cars that contain all that's needed for boring the tunnel, just like an underground factory. These contain generators, an electricity distribution unit, rescue chamber and workshop, as well as the operator's cab from which the pilot controls the tunnelling machine. Throughout the tunnel, there are water pipes, high-voltage cables, conveyor belts and ventilation. The cutter head is 5 metres in diameter. It has 28 steel cutters weighing approximately 200 kilograms each. As the cutter head rotates, the cutters create a considerable pressure against the rock. This causes the rock to chip and fall onto a conveyor belt. The tunnel boring machine is subject to wear, which requires regular service and maintenance. The cutters are subject to the most wear. When they need to be renewed, they're removed, lifted down and replaced. This is carried out from the back side of the cutter head. When drilling is in progress, the entire machine shakes. The noise level is over 100 decibels. A conveyor belt takes the rock masses out of the tunnel to a silo in Anneberg and down into a rock cavern. Here, the spoil is then transferred onto trucks. This takes place in the rock cavern to disturb local residents as little as possible. The spoil can also be stored in the rock cavern for a short period. The spoil is driven to reception facilities to be processed and reused, in road construction, for example. An average of 70 metres of tunnel are drilled a week. This creates approximately 1,400 cubic metres of rock, or 70 truckloads. The tunnel boring machine moves forward by bracing itself against the tunnel wall with grippers. The rest of the tunnelling machine follows the cutter heads on rails. The rails are moved forward with the machine so as not to be left lying along the tunnel. As drilling progresses, water pipes, conveyor belts, ventilation ducts and high-voltage cables are extended. Safety is a high priority to ensure that no one is injured. Safety equipment and working methods are reviewed regularly, and the personnel practice how to evacuate the tunnel. Work and preparation are carried out methodically before the tunnel boring machine starts. First, the rock mass conditions in front of the tunnelling machine are investigated. The shift team carries out exploratory drilling and perform water loss measurements to find out about the rock and the need for grouting. They drill 4 exploratory holes, approximately 20 metres in front of the cutter head. These holes are filled with pressurised water. This gives an indication of the fissures in the rock, how water-bearing the fissures are, and determines the need for grouting. After that, an assessment is made of how much grouting is required. Prior to grouting, some additional 20-metre holes are drilled in front of the tunnel face. Cementitious grout is pumped into the holes at high pressure to seal fissures in the rock around the tunnel and to reduce the amount of water inflow. The grout used consists of cement and water. It's mixed on board the tunnelling machine and checked thoroughly to ensure the correct quality. The deeper the tunnel is underground, the higher the pressure needed to withstand the groundwater pressure. The amount of water that can flow into the tunnel is governed by the project's environmental court ruling. The permitted volume of water varies in different sections and depends on how sensitive the environment has been assessed at that point as not to cause harmful groundwater subsidence. Several rounds of grouting may be needed to seal the tunnel adequately. There are also sections where grouting is not needed at all. When grouting has been completed, the cement must cure before tunnel excavation can continue. The grouted rock looks like this. When grouting is complete, the tunnel boring machine is started, setting its sights on another 20 metres before the next round of exploratory drilling starts. The rock is continuously reinforced so that the tunnel is safe to work in throughout the tunnel's service life. Reinforcement is tailored to rock conditions and to requirements. Installing rock bolts and shotcrete is usually enough. Loose rock that might otherwise risk coming loose and falling down is manually removed. The project's environmental court ruling governs the working hours for tunnel boring based on its effect on buildings in the surrounding area. For a large part of the route, tunnel boring can only be carried out between 7 AM and 10 PM so as not to disturb residents at night. The water used in production is treated and sampled before it's released into the municipal surface water network. When the tunnel is completed, it will be handed over for the installation of the cable system. The tunnel between Danderyd and Hammarby Sjöstad is a new vital highway for Stockholm's electricity supply.